Yes, in this lecture we will going to discuss the mechanical properties of the solids. Now this lecture will going to helpful for JEE and NEET preparing students. Okay, myself Mallikarjun. Now I will going to discuss these topics by using the basics concepts, and after that I will going to solve some JEE and NEET questions so that these concepts are crystal clear. Okay, yes. Now first we will start with this stress. So what is stress? So if any body gets deformed under the action of an external force, at each and every section of the body an internal resisting force will going to create. So this internal resistance created that tries to restore the shape of the body, try to restore the original shape of the body. So this internal resisting force per unit area that will going to give us a stress. So mechanically how we're going to define this stress is if any body is subjected to an external force F. Okay, this is called as tensile force. No, because of this applied force this body creates internal resistance. Each and every section the internal resistance is being created. Now at section AA I will going to take the internal resisting force. So with respect to this section AA, now this is the internal resisting force. This is the internal resisting force. Now this internal resisting force per unit area, this sectional area, that will give us a value of stress. So internal resisting force per unit area, that will going to give us a stress. The unit of stress is Newton per meter square, or it is Newton per mm square. This Newton per mm square is also known as megapascal. Okay, Newton per mm square is also known as megapascal. So if a question is asked on this stress, though simply a stress is internal resisting force per unit area, unit cross-sectional area. The unit of this is Newton per meter square, or Pascal, or megapascal. Okay, the same thing is explained here. The unit of this is Newton per meter square, or Pascal. The dimensional formula for which is ml raised to minus 1 t raised to minus 2. This is the dimensional formula. This has been repeatedly asked in the NEET and JEE exams for 1 marks. Okay, just you can remember this. Okay, there are types of stresses are there. Longitudinal stress, tangential stress or shearing stress, and normal stress. Okay, we will going to discuss one by one these stresses. Okay, now this is the one question already asked on the stress. What is the unit of stress? This question is also asked. And what is the dimensional formula for this stress? So dimensional formula for this stress is equal to force per area. So dimensional formula for force is m l t raised to minus 2. So area is l raised to 2. It is m l raised to minus 1 t raised to minus 2. So answer is B, m l raised to minus 1 t raised to minus 2. Clear? Yes. Next, there are different types of stresses. First one is a longitudinal stress. The longitudinal stress is being classified as tensile stress and compressive stress. Okay, now what actually tensile stress? A tensile stress always tries to increase the length of the body. Okay, see here, this is the tensile force. F is known as tensile force. These are equal and opposite. These forces are equal and opposite. So these always tries to increase the length of the body. Okay, then the stress created inside the body is known as the tensile stress. So if there is an increase in the length of an object under the effect of applied force, then the stress is known as this tensile stress. So this tensile stress unit is also same thing, is a Newton per meter square or megapascal. Next, compressive stress. If a compressive stress is like this, these two forces are equal and opposite. They tries to decrease the length of the body. They tries to decrease the length of the body or object under the effect of applied force. The stress generated inside the body is known as the compressive stress or compression stress. Next, tangential or shearing stress. If a deforming force acts tangentially to the surface, consider this is the surface. Okay, this is the object. Okay, now this is the surface of the object. Let us suppose this is the object, this is a three-dimensional object. Okay, now this is the surface of the object. Now I will going to apply the force along the surface. Okay, now this tries to shear off the surface of a body. This applied force try to shear off the surface of the body like this. This get shifted to here. The surface get shifted to here. Okay, now this is the angle created. If this is the body and this is the surface after shearing, the surface gets slides after the applying a force F. So this is angle theta. Okay, this is angle theta. So if you take this as x, okay, this as x or h, okay, and this as force F. So tan theta is equal to F divided by x. So by using this theta, we will going to define the shearing stress or tangential. So if a deforming force acts tangentially to the surface of a body, it produces a change in the shape of the object. The tangential force applied per unit area is known as the tangential stress. Clear? Yes. Next, normal stress. If a body is subjected to uniform force from all sides, so normal stress is like this. If a body is like this, now if the force is acting like this, like this, like this, and like this, uniformly subjected to a force in all over the direction, then corresponding stress inside a body is known as the normal stress. Clear? Okay. If an object is under water, is subjected to a normal stress. If an object is immersed in the water, is subjected to a normal stress. Next, now this is a question asked in the NEET 2023. The question is like this: if a wire is suspended from the ceiling, let us suppose this is the wire is suspended from the ceiling, this support is rigid and stretched by a weight of W. This is stretched by a weight of W and attached at the free end. This weight is attached at the free end. This is the free end. The longitudinal stress at any point of cross-sectional area A of the wire, any cross-sectional area, this may be A cross-sectional area or this may be B cross-sectional area. Okay, this is the uniform cross-sectional area. So what is the longitudinal stress? So the answer is very simple. The longitudinal stress is the internal resisting force per unit area, so along the length of the wire. So at AA or BB immaterial, wherever you are taking the uniform cross-sectional area. So at AA the cross-sectional area is A. So what is the force inside the wire after applying force? Is a equal force, internal force is been generated, is a W. So W by A is the longitudinal stress. So answer is B. Clear? Yes. Next, strain. When a deforming force acts on a body, the body undergoes a change in its shape and size. The fractional change in the configuration is known as the strain. Or simply, the strain is the change in length of the body to the original length of the body. Okay, the after applying force, if this is the body, length of the body is L, just you can apply a force F. Okay, let us suppose this is fixed like this here. So this is increase in the length of the body after applying a force. This is the delta L, this length is delta L. So this change in length of this body to this original length, what is the original length? L. This is the original length. What is change in length? Delta L. Delta L divided by L. How much change in length to the original length? That will give us the strain. So you will be normally asked what is the unit of strain. So unit of strain is no unit. This doesn't have any unit because change in length is also in meter, original length is also in meter, meter get cancelled, so this doesn't have any unit. So the question is usually asked what is the unit of strain. Unit of strain is Newton per meter square. It is a unitless and it is megapascal. These are some answers given. So answer is unitless or no unit. So this is regarding strain, and this strain is also classified as a longitudinal strain, volumetric strain and shearing strain. So longitudinal strain is change in length to the original length. Longitudinal strain along the length of the object. Volumetric strain is related to the volume, is a change in volume to the original volume. Shearing strain is a tangential applied force to the area of force. Shearing strain, tangentially applied force to the area of the force. Next, Hooke's law. Hooke's law is related to the elastic limit. For a stress strain diagram, till elastic limit of a body, the stress is directly proportional to strain. If you take a stress strain diagram for mild steel, the mild steel stress strain diagram will be like this. So till elastic limit, the stress is directly proportional to strain. So if you remove this proportionality symbol, we are going to get a constant. This constant is known as the Young's modulus. Okay, so this Young's modulus is stress divided by strain. So unit of Young's modulus is same as that of stress. Okay, so the Young's modulus is also known as the modulus of elasticity or elastic modulus. This depends on the type, this depends on the material, some material property. Okay. Next, Young's modulus. Young's modulus, as I told you, it is also known as the modulus of elasticity, and it is defined as the stress to the strain. It is a mechanical property of a material. Okay. So the Young's modulus is also referred as the elastic modulus or tensile modulus or modulus of elasticity, is a measure of mechanical properties of linear elastic solid like rods, wires, such as such other members measures the elastic properties of a material like bulk modulus, shear modulus, and other Young's modulus is commonly used. So this Young's modulus E, as I told you, this is a stress to the strain. This stress is referred as internal resisting force per unit area, is the F by A. This strain is change in length to the original length. So what is the change in length of a body? That can be written as delta L equal to F L will go here, F L divided by A E. A just will come down. Okay, F L divided by A E, or in place of F sometimes P is also used, force, P L divided by A. So please remember this formula. So what is change in length of a body? So change in length of a body is proportional to force applied and the length of the object, and inversely proportional to area and Young's modulus. So the PL divided by A. Okay. Now in this question, sometimes the force P is given, Young's modulus is given, area is given. So you will be asked to find out what is the change in length of a body. Sometimes you will be asked to find out what is stress generated. Stress generated is also sigma L divided by E. So P by A is sigma, is a stress into length to the Young's modulus. You may be asked to find out what is stress in a body after giving what is length of body, Young's modulus, and change in length. So you are able to calculate any parameter in this question. Okay, just you can remember this formula. Okay, next, this is the question which was already asked in the NEET. So here, for the following 4 wires are made up of same material, which of them will have the largest extension when the same tension is applied and same tensile force is applied? So which wire will going to show the largest extension? Okay, the length of wire and diameter of wire is already given. So among these 4 wires, which one will going to show the more extension? More extension means more delta L. So delta L already I told you is a PL divided by AE. So here length and diameter are given, so it is proportional to length, and diameter is 5 by 4 d square, 5 by 4 d square, so it is proportional to L divided by d square. So for first wire, so delta L1 is proportional to L1 50 divided by d square. 50, this length 50 you can convert into mm, it will be 500 into 10. Okay, and the diameter is in mm, is a 0.5 square, 0.5 square. Okay, next, second one, delta L2 is proportional to 1000 1 square. Third one, delta L3 is proportional to 2000 divided by 4 square. Fourth one, delta L4 is proportional to 3000 divided by 3 square. So just you can solve this. We will going to get this as 0.5 into 0.5 in the denominator. So this we will going to get it as 5 into it is 0.5 here, 0.5 here. In the numerator we will going to get around 2000. Just you can check it. Okay, and for this one we will going to get it as 1000. This one 500 for 4 and 4 ones are 4 twos are and 5s are. Okay, delta L3 we will going to get it as around 500. Okay, 4, it is 4. Okay. And this one we will going to get it as around 333. Just you can check it in this one is larger. Okay, so answer is first one. So first wire shows the maximum extension. Clear? You can see the next question. Two wires are made of same material is same, means Young's modulus is same, and have same volume is same. Okay, the first wire has cross sectional area A and second wire has cross sectional area of 3A. This is first wire, this is second wire. The length of first wire increased by delta L on applying force F. How much force is needed to stretch the second wire? Here force F is applied. How much force is required to stretch the second wire? So you can read the question one more time. Two wires are made of same material and have same volume. The first wire has cross sectional area A and second wire has cross sectional area 3A. If the length of first wire is increased by delta L on applying a force F, how much force is needed to stretch the second wire by the same amount? By the same amount means this is also delta L. Young's modulus is also same. E is also same. So only force is asked. So just you can write down the equation. Is the delta L formula is PL divided by AE, P1 L1 divided by A1 E1, P2 L2, P2 L2 divided by A2 E2. Okay, so volume of the material is same. Volume of the material is same means A into L gives us volume of first material and A2 into L2 is for second. Here area first is A and second is 3A. So just you can substitute A here. Length L1 is 3A, length L2. So L1 equal to 3 L2 or L2 equal to L1 by 3. So just you can substitute here. I need to calculate P1 or P2. P2 I want to calculate. It is already given P1 as force F1. P1 already given as force F1. Okay. Okay. Yes. Okay. This is a force F. L1 is L1 only. Area is A. Young's modulus is same because material is same. This is force F2. In place of L2, just you can put L1 by 3. A2 is what? 3A. So AA get cancels. L1 get cancels. So F2 will be equal to this 3, it is a 9 numerator. So it is 9F. So the force in this second material is equal to 9F. F means it is a F1. So 9F. So this is the answer. Clear? Okay. Next. Young's modulus of steel is twice that of brass. Young's modulus of steel is twice that of brass. Just you can take steel and brass. Steel I will going to take it as ES and brass will be EB. Okay. So Young's modulus of steel is twice that of brass. Two wires of same length is same. Okay, and of same area of cross section, one of steel and another of brass are suspended from the same roof. They are suspended from the same roof. This is S, this is P. Okay, if we want the lower ends of the wires to be at the same level, means change in length. To be at the same level, then the weight added to the steel and brass wire must be in the ratio of, so weight added for steel to the weight added for the brass. This ratio here is asked at the same level. If the level is same, means there is no change in length. Change in length of the wire is same. So just you can equate this change in length of the wire for steel and brass, we will going to get the answer. So in this question, what he has asked, if you want to lower the ends of these wires at the same level, then the weight added for steel to brass. This question is asked. Weight added means force applied. After applying force at the end, this is PS, this is PB. Okay, they should be at same level. They may extend also, but this delta L change in length will be same. So just you can write down this equation: PS LS divided by AS ES equal to P B L B A B E B. Okay, so Young's modulus ES is equal to 2EB. Okay, A get cancels because these are equal. These are equal. Okay, and PS by PB, PS by PB, PS by PB equal to LB by LS. LB by LS, this length is also same. This is also get cancelling. Okay, then what else? ES by EB. So ES by EB. So ES is ES only. ES you can take it as 2 EB. This is EB. So EB get cancelled. It is PS divided by PB is equal to 2:1. So answer for this is 2:1. So the ratio of weights added for steel to the brass is 2:1. Okay, answer is very simple. Okay, next, these questions already asked in NEET and JEE. Same questions only solving here after explaining each and every concept. Okay, just you can go through this question and afterwards you can see the theory behind this. So all these questions I am solving based on this only one formula, delta L is equal to PL divided by A. Okay, yes. Next you can see the question. A wire of length L, this is the wire of length L, okay, and cross-sectional area A is hanging from the fixed support. It is hanging from the fixed support. If this is the length of the wire, okay, the length of wire changes to L1 when mass M is suspended. It changes to L1 when mass M is suspended here. Okay, at the free end, the expression for Young's modulus is, so what is change in length? L1 minus L. This is change in length. So what is Young's modulus? Change in length will be equal to, change in length will be equal to force P L divided by AE. What is force applied? M. Force applied is M. Since this answer are in Z, just you can write down M into Z, the weight, mz. M is mass, okay, just you can write down in weight, mz, into L, A into E. Okay, so in this you can take out Young's modulus. So what is Young's modulus? E. So Young's modulus E is mzl divided by A delta L. Delta L is what? L1 minus L. So what is the answer? mzl A L1 minus L. This is the answer. Okay, next question you can see. If the ratio of diameters, length and Young's modulus of steel and copper wires shown in figures are P, Q and S respectively, then corresponding ratio of increase in their length would be. This is the question. Okay, just you can try. The diameters, lengths and Young's modulus, these ratios are given. So the diameter ratio, the length ratio and Young's modulus ratio, these ratios are given as P, Q and S. So this ratio is given S to C, means steel to copper. Then corresponding ratio of increase in their length would be, increase in their length, this is steel wire, this is copper wire. Okay, so increase in their length, so increase in their length, this is the question. Okay, so for this particular question, for each wire what is the force generated? For copper wire what is the force generated? For this is the copper wire attached here, So this is the copper wire attached here. It is hanging with 5 m of weight. This 5. Okay, and steel is suspended with both 5 and 2 weights, so it is 7. 5 m and 7 m, these are weights. Okay, so these are in series. Extension in wire is same. Okay, extension in the wire is same. Just you can equate the PL by AE equation for both the wires. This is a PL divided by AE for steel, PL divided by AE for steel, and PL divided by AE for copper. Okay, PL divided by AE for copper, and these ratios just you can note down. And we need to find out the increase in length. Just increase in length for same for these two material, it is increase in length is same. Okay, increase in length is same. Okay, now just you can cross multiply these two. Just you can cross multiply for PS. For a diameter you can see this is S, no, so this is PS divided by PC. PS divided by PC is 7 by 5. So PS divided by PC. PS divided by PC here. PS divided by PC. Next, LS divided by LC, it is Q. Next, AS divided AS, AC will move here, so AS by AC, AS by AC, it is a DR. A is defined with A is proportional to D square, so it is P square. Correct. Next, ES by EC, ES by EC, so it is yes. Okay, now this would be 7 by 5 into Q into S into P square. So answer would be 5S P square 7Q. B is the answer. Okay, now such type of questions will be solved systematically like this. Okay, next question, just you can try this question. Okay, I will going to give you 5 minutes. 1 minute, just I will open this. Yes, just you note down this question and just you can try this. So in this question he has asked the nature of a graph. He has given copper of fixed volume V is drawn into a wires of length L. When the wire is subjected to a constant force F, the extension produced in the wire is delta L. Which of the following graph is a straight line? Straight line like graph. Okay.